Hashtag the science behind language acquisition. Have you ever watched a child effortlessly pick up a second language while an adult struggles for years just to order coffee abroad? That gap is not about intelligence. It is not about effort. It is about biology, timing, and the remarkable architecture of the human brain. Today, we are going deep into the actual science behind how human beings acquire language, what makes it succeed, what makes it fail, and what every language learner on the planet can do with that knowledge right now. Language acquisition is one of the most studied phenomena in all of cognitive science. Linguists, neurologists, psychologists, and educators have spent decades trying to crack open the black box of how we go from knowing 0 words in a language to dreaming in it. And what they have found is both humbling and incredibly empowering. Let us start at the beginning. Every human being is born with what linguist Noam Chomsky famously called the language acquisition device, or LAD. This is not a physical structure you can point to on a brain scan. It is a theoretical framework describing the innate predisposition humans have for language. Chomsky argued that children could not possibly learn language purely through imitation and correction because the input they receive is far too limited and messy. He called this the poverty of the stimulus. Yet children consistently crack the grammatical code of their native language by age 5. That suggests something deeper is happening inside the brain itself. Neuroscience supports this idea. At birth, your brain contains roughly 100 billion neurons. In the first few years of life, those neurons form synaptic connections at a breathtaking rate, sometimes 1 million new connections per second. Language is one of the primary drivers of that connectivity explosion. 2 regions become especially important. Broca's area, located in the left frontal lobe, handles language production and grammar processing. Wernicke's area, in the left temporal lobe, handles language comprehension. When these 2 regions communicate efficiently through a neural pathway called the arcuate fasciculus, fluent language use becomes possible. Now here is where it gets fascinating. Research shows that bilingual individuals actually have denser gray matter in these language processing regions. A landmark study published in the journal Nature in 2004 by researchers Ellen Białystok and colleagues demonstrated that people who spoke 2 languages regularly showed significantly greater cortical density in the left inferior parietal cortex compared to monolingual subjects. This suggests that language learning does not just use the brain. It physically reshapes it. That is neuroplasticity in action. But there is a critical window for all of this, and this is where the biology gets both fascinating and slightly sobering. Scientists call it the critical period hypothesis, first proposed by neurologist Wilder Penfield and later championed by linguist Eric Lenneberg in the 1960s. The theory states that there is a biologically determined window, roughly from birth to puberty, during which language acquisition happens most naturally and completely. During this window, the brain remains highly plastic, meaning it bends and molds itself around language input with remarkable ease. After puberty, that window does not slam shut entirely, but it narrows significantly. The brain becomes more specialized, less flexible, and acquiring a new language requires considerably more conscious effort. This is why most adults never fully eliminate a foreign accent. Phonological acquisition, the ability to hear and reproduce the precise sounds of a new language, is particularly sensitive to this critical window. A child raised bilingual from birth will typically sound native in both languages. An adult learner almost never will, regardless of how many years they study. Stephen Krashen, one of the most influential applied linguists of the 20th century, built on this understanding with his input hypothesis. Krashen argued that we acquire language when we receive comprehensible input, meaning language that is just slightly beyond our current level of understanding. He labeled this concept I+1, where I represent your current competence and +1 represents the next level of complexity. Too simple and your brain disengages. Too complex and you comprehend nothing. Hit that sweet spot and acquisition happens almost automatically. This concept directly explains why immersion works so powerfully. When you are surrounded by a language and forced to make sense of it in real contexts, your brain receives a continuous stream of comprehensible input calibrated naturally to your growing ability. Studies of immigrants and foreign exchange students consistently show that immersive environments produce faster acquisition than classroom instruction alone. A 2012 analysis by researcher Robert DeKaiser found that adult learners in high-intensity immersion programs progressed through proficiency levels approximately 3 times faster than those in traditional classroom settings. But immersion alone is not the whole story. Comprehensible input must be paired with what researchers call noticing. Cognitive psychologist Richard Schmidt introduced the noticing hypothesis in 1990, arguing that learners cannot acquire a linguistic feature unless they consciously notice it in the input they receive. This is why you can hear a foreign language for years without improving if you are not actively attending to its structure. Passive exposure without attention produces little acquisition. Active, engaged noticing accelerates it dramatically. This brings us to the emotional and psychological dimension of language learning, which is far more scientifically significant than most people realize. Linguist Stephen Krashen also developed what he called the affective filter hypothesis. The idea is that emotional states function like a filter between incoming language input and the brain's language acquisition mechanisms. When a learner feels anxious, embarrassed, or unmotivated, this filter rises, blocking acquisition even when comprehensible input is present. When a learner feels safe, curious, and engaged, the filter drops, and input flows directly into deep acquisition. Neuroscience validates this beautifully. The amygdala, the brain's emotional processing center, directly influences the hippocampus, which is responsible for memory formation and consolidation. When you are stressed, the amygdala floods the system with cortisol, which actively impairs hippocampal function. In plain terms, stress chemically interferes with your ability to form new memories, including language memories. Conversely, positive emotional engagement triggers dopamine release, which strengthens memory consolidation. This is the neurological reason why people learn faster when they are enjoying themselves. Fun is not a distraction from learning. Fun is literally the chemical environment in which learning thrives. Sleep is another scientifically critical and chronically underappreciated component of language acquisition. During sleep, particularly during slow-wave and REM stages, your hippocampus replays and consolidates the information it gathered during waking hours, transferring knowledge into long-term memory storage. A 2014 study from the University of Geneva demonstrated that learners who slept after a vocabulary learning session retained nearly twice as many words 24 hours later compared to those who stayed awake. This means the 8 hours after a study session may be nearly as important as the study session itself. Output also plays an irreplaceable role that pure input theories sometimes underestimate. Merrill Swain's output hypothesis, developed in the 1980s, proposed that producing language, whether speaking or writing, forces learners to notice gaps in their own knowledge that input alone does not reveal. When you try to say something and realize you do not know how to say it, that moment of productive failure creates a powerful learning opportunity. The brain flags the gap, making you hypersensitive to information that fills it. This is why speaking practice, despite being uncomfortable and error-prone, is cognitively irreplaceable. What does all of this science mean for the practical language learner sitting at home with a textbook or an app? It means several things with remarkable clarity. Massive, varied, emotionally engaging input is not optional. It is the core mechanism of acquisition. Grammar study has value, but only when it supports noticing in authentic contexts, not as an end in itself. Sleep must be protected as a biological necessity for consolidation, not traded for extra study hours. Emotional safety and enjoyment are not luxuries. They are neurological requirements. And regular output practice, even imperfect and stumbling, creates cognitive demand that accelerates growth. The research also challenges some deeply held myths. The myth that adults simply cannot become fluent in a foreign language is not supported by science. Adults lack the phonological sensitivity of young children, but they compensate with superior analytical ability, larger existing vocabulary frameworks, and greater metacognitive awareness. A motivated adult learner using research-backed strategies can reach advanced fluency in virtually any language. The timeline may be longer.